Hello, welcome to lesson 3 of our cybersecurity training for beginners. In this lesson, I'm going to be taking you on network and network security, part 1. There's a series of lessons that will come under this lesson 3, and that is going to be under the network and network security. You're going to be understanding what the network is and how to secure network for effective performance. That is the bedrock of cybersecurity. So I welcome you to this training today, and I'd like you to take your time and take your journey with me as we dissect network and network security. Now, as a way of introduction, let's look at what we are going to be covering in the section of network and network security as a cybersecurity analyst. Whether you're a beginner or you're an experienced user, you're going to learn a lot from here because this is where it begins from. This lesson will help you to understand the basic structure of a network, which we also call network architecture. So you need to understand the basic structure, the component that make up the network. That is what this lesson is going to help you to understand, and also the commonly used network tools, the tools that we use on the network. You're also going to be learning about network operations and explore some basic network protocols, the protocols that are used to communicate on the network. From one device to another, you will learn in next. You will learn about common network attacks and how network intrusion tactics can prevent a threat to a network. When we are concluding the series of the network and network security, I'll be providing you with an overview of security admin practices and how you might use them to help secure a network. And if you are watching this video, you have not subscribed to this channel, this is the right time as well to go ahead and subscribe. So now let's go further. What are networks? A network is a group of connected devices. When you have devices that are connected together, maybe you have one device here and then you have another device. And then when we talk about device, we are talking about it could be your PC, okay? It could be your phone, okay? It could be your tablet, it could be your printer, it could be a switch. That's what we mean by a device. Any device at all. In fact, it can be your smart TV. That is also a device that can connect to a network. So a group of connected devices is what we refer to as a network. Now you can see from here, these are a group of connected devices. You have a smartphone, you have a laptop, and then we have a desktop. They are all connected to a wireless router that you have at the center here. And this network as well can also talk to somebody outside. Okay, that is with the addition of a router to a network. For example, the network can then communicate with another network in another location. We're going to be discussing that fully as we proceed further. Now let's look at the types of network that we have. We have what you call a local area network, which is LAN. Okay, a local area network span a small area like an office building. Network in your house, for example, in an office building, in a school, at home, they are all referred to as a LAN, local area network. Okay, and then you can also connect. The example that I gave concerning your phone, connecting other people together, is actually a LAN, a local area network. That is what the LAN is all about. And you can see the picture from here. Your LAN can also connect to the internet with the help of a router. So all of these devices right here, let's say this is somebody in your house or in your office, and then they are using PC1, PC2, and PC3, and they're connected to this wireless router. So they are actually forming what we call a LAN, local area network. Okay, the LAN then connects to the internet, as you can see. So your LAN then connects to the internet. This is why you discover that even if you don't have an internet on your wireless router that you have at home, if there is no subscription, there's no internet there, people can still connect. The only thing is that they are not able to browse the internet. They are not able to access the resources on the internet, but they can form a LAN, which is local area network, and within themselves they can send file to each other or share file within one another without actually connecting to the internet or go to the internet. That is what we refer to as a local area network. Now next to that is WAN, which is wide area network. This one span across geographical area like a city the state, or the country. As a matter of fact, you can think of the internet as one big one. So an employee of a company in one country, let's say this is a country, okay, let's say this is US, an employee in this country can connect to another employee in another country, let's say UK here, via the one wide area network. So that is one. It span across geographical area, wide area, not just an office building, not just a house. This time around, it could be across the state, across the city. So, and that connection is made available or made possible with the help of internet. So that is what we refer to as wide area network. So those are the two major types of network that we have. Now let's look at the tools that we use to connect on the network. Remember that I said that when we define the network, we said network is a group of connected devices. Okay, how are these devices going to connect together? For the devices to connect together to one another, they actually need a kind of connection point. So that connection point is exactly what we are going to be discussing right now. That is what I mean by network tools. We are going to be looking at the tools that we use on the network. The first one we are going to talk about there is a hub. Okay, a hub is a network device that broadcasts information to every device on the network. Think of a hub like a radio tower that broadcasts a signal to any radio that tuned to the correct frequency. That is what a hub is all about. This is a radio tower here, and this radio tower is broadcasting signal right now. It means that anyone that tuned into the frequency will be able to actually pick up the signal and connect to the station. That is the way the hub behaves. So on the network, when it comes to the hub, this is the problem that we have with it. A packet that are moving on the network can actually go to a wrong location, or the device that you don't want that packet to go into. So that is why if you check most of the secure network today, you are not going to see the hub on a network because of this. Now let's talk about the switch, which is a second device or network tools that we can use on our network. A switch makes connection between specific devices on a network by sending and receiving data between them. A switch is more intelligent than a hub because it's only going to pass the data to the intended destination. Now, let's say we have a computer here. This is your PC. I call it PC1. And then you want to send to somebody else that is on the network. This is PC2, right? And then we have another user here. Let's call this one PC3. Okay, this PC3 is, all of them are connected to each of the ports that we have on the switch here on the hub. So we have a port here. Let's say this is connected here, this is connected, this is connected. Now, if the user 1 want to send a file to user 2, what happened with the hub is that the information that you are sending across, that as it's coming through this line from this port, is going to broadcast to all the ports, like the radio signal that I put over here, like a tower. It's going to broadcast to all these ports. So PC3 will see the information, PC2 will also see the information. But that's not what exactly you want. You want a situation whereby if I'm sending from 1 to the user 3 or user 2, user 2 is not supposed to see the information. Okay, that is where the switch comes in. The switch is more intelligent than a hub because it will only send that data to the intended destination. It's not going to broadcast it to all other devices on the network. Say, hey, I'm bringing in a file for you. Are you there? So it's not going to do that. It's actually going to direct the file you are sending or the traffic you are sending to the direct destination. So that is why a switch is more intelligent than a hub, and its hub is never recommended on a network because of that. There's a lot of issue with hub. So I'm just mentioning that so that you learning as a security analyst, you get a network and you discover that they are using a hub to connect in that office, you should be able to first of all see that as a red flag for security incident. So that is why a switch is more intelligent than a hub. This makes switches more secure than a hub, like I said, and enable them to control the flow of traffic and then improve the network performance, because the data packet that is coming from user 1 is going to go directly to user 2. If you send it to user 2, It's not going to broadcast to all the 48. Now, if this is a 48 port switch, it means that 48 devices can connect to this network with wire, can form a network with wire. That's what this means. If this is 48 port switch that we have over here, it means that you can have 48 devices connected together to form a network. Now, if only one of them want to send information, it will only go to the designated port that you are sending it to, not to all the 48 first. So that means it makes the communication to be more secure. There's not going to be a collusion, because when one port is sending and another one is sending, each one of them go directly to the destination that they are intended for. Now, the next one we are going to be talking about is a router. That is another network tool or device that we have. A router is a network device that connects multiple networks together. Now, let me try and differentiate between a router and a switch here. Your switch is going to connect people locally, LAN. We use the switch to form a LAN. Even though today we have what you call layer 3 switches that are actually being used as even a router that you can use to route a traffic as well. But traditionally, or let me say at this level, at the beginner's level, we see a switch as a layer 2 device, which means that it is used to connect locally. You can connect information locally, local area network. We use a switch to form a local area network where different devices are connected together. Now, if you have one network at home, you have another network at office, or one network in one location, maybe your branch office, and you have another network in another location. You want to connect the two networks to talk to each other. This is where the router comes in. You are going to need a router to be able to do that. So the job of the router is to bridge two networks together. So this is network 1. Okay, then you want to talk to another network in this location. This network as well has several devices are connected to it, and then we call it network 2. So you need the network 1 in one location. It doesn't matter where the location is. It can be within the country, it can be outside the country, it can be from one office branch to another branch of the office. All you need to do is to have a router. Okay, it's the router that is going to bridge the communication and allow two different networks to communicate together. So that is why from here you can see I said a router is a network device that connects multiple networks together. For example, if a computer in one network wants to send information to a tablet on another network, then the information will be transferred as follows. Look at this practically. This is a PC want to send an information to another PC over here. They are on two different networks together. So you need a router to be able to pick up the information and then find out from this router where is the address of my destination, and then the information will come to the router. The information you are sending from this PC will go straight to this router, and this router will forward it to another router, and this router will forward it to intended destination. Now, between this source and the destination, the source, which is the sender, and the destination, which is recipient, you can have several router along the line. It depends on the destination and where the destination is. So you can go through several routers, but all these things happen within the split of a second, okay, for the destination to be delivered. Now, the last network device we are going to be discussing is a modem. Let's talk about a modem. You can see a modem as we have it in this diagram. It's a device that connects your router to the internet. Now, we talk about a hub, and we said what the disadvantage of the hub. Then we said a switch is used to form a network better than a hub because it's more intelligent than a hub. And we now say when we form a network, that network is a local area network. We want the network to talk to each other. Then we bring in a router. Now, after the router, what next do I need on my network to have a proper network to talk to the internet is also what we call a modem. Look at this modem now. This is a router now. This network now needs a modem. All right. Now this modem, then before you can now talk to the internet. So that's how the network connection actually, a proper network connection will begin with a switch. Okay. You have devices that are connected to the switch. From the switch, it will move to a router, which will enable you to connect to another network. And from there, it can definitely move from the router directly to a modem. Okay, this modem then allow you to connect to the internet. So those are the basic network device that we have, and I think it's very important for you to understand as a beginner. You understand what a hub is, what a switch is, what a router is, and then what a modem is, and the function of each of these network devices that we have discussed. Now, let's go further and talk about the network architecture. Now that you understand the network devices, how these devices come together to form what we call a network design or a network diagram. So all of these names, they mean the same thing. So you need to understand a network diagram as a network, as a security analyst. You need to understand network diagrams allow network administrator and security personnel to imagine the architecture and design of their organization private network. If you are hired today as a security analyst, the first thing you need to study actually is the network architecture. You need to understand where are the devices on the network and how are they connected together. That is when you can know whether, okay, the connection, or let me say the architecture, is looking good, secure enough, or it can also be hardened in order to add additional layer of security to it. So if you don't understand the network architecture, there is no way you can protect a network. So this is why I'm spending some time in order to explain the network diagram, network devices, so you can know what they do and the function of each of them. So this is a network diagram. As you can see from here, like we said, this is like a LAN network. Okay, with the help of this switch, all of these networks are connected together. The server is connected to the switch. This router as well is connected to the switch. What this one is doing is to extend the network, okay, for those people that want to connect wirelessly. Because some device like your phone can definitely not connect to the internet using a cable. It will be a wireless device. So you want to add a wireless router, for example, to an existing local area network. That's exactly what happened. This is a switch. It has several ports. So all of these devices you are seeing here, they are connected with cable directly to each of the ports that you have on the switch. So you have a network printer here, okay, and the second switch is being used by this desktop, and then you have another port that is being used by the server. You have another port that is being used by this laptop. You have another port on your switch that is being used by another laptop. So you can have a switch that can do 24 port, 48 port. The number of ports that you have will actually determine the number of physical device that can connect to that port with cable. So but now we now have some other devices in the office that they are not cable. They can't connect with cable, want to connect them wirelessly. Then we had a wireless router to the network. So this is a wireless router, for example, right now. This wireless router has been added to one of the ports on the switch. So whatever is configured on this switch will definitely be received by the wireless router. And the router will broadcast that wirelessly to all the devices that you allow to connect to the router via wireless. So you can see the smartphone and some other laptop, especially sometimes when you exhaust the port, the physical port that you have on your switch, you might want to just use one of the ports to have a wireless router connected to it so that you can broadcast through wireless and the other devices can connect with wireless. Now, all of these devices that we now have here actually want to talk to outsider. They want to connect to the internet. So for them to be able to do that, remember I said it, when you have one network, want to talk to another network, or you want to go online, you are going to need a router. A router is actually what is going to pick the address inside and be able to relate it with address outside and be able to locate, where you want to talk to outside. Anytime you want to go out of your boundary, out of your local area network, you will need a router to help you in order to be able to go out of that. Okay, so you can just consider that like an immigration officer that is helping you to navigate and helping you to get out of your country, probably to another country, or to do something else outside of your boundary. That is what the router is doing here. Now, we want to make this network to be more secure. We now think about it. What happens when I'm sending a file? The router should not just pick the packet. When that information gets to the router, Okay, before the router will send it out, you want to put a firewall. This is another layer of defense. Okay, the firewall is to allow, based on whatever rule that you define on the firewall, you don't want everybody here to be able to talk to everybody outside. So that's why you need a firewall. And you don't want everything outside to be able to talk to your internal network as well. So the firewall, you can define on this firewall who should talk to what should talk to what. Probably you want to block some website. Okay, you want to block, okay, don't block YouTube anyway. You want to block some websites. You don't want people to use that, that website when they are in office during the working hour. You can come to the firewall and then you connect the firewall before you get to the modem, because modem will take them to the internet. So before they go to the internet, you are telling the firewall, if anybody is coming from inside there and is coming with so port, or is coming with so IP address, okay, don't allow that person to be able to get to a particular website. So whatever information they are sending, it will be dropped by the firewall and it will not allow you to go through. The same thing from here as well. Any information coming from outside, from the internet, you can define the firewall to allow what will come into your network and what should not come in onto the network. So from the firewall, then you get to your modem. This can be your ISP modem, internet service provider that is providing you with the internet, and then you have access to internet where you can access all the services that we have on the web. Okay, so that is actually how the architecture of a network is all about. So this kind of network right now is not the most secure network, but it's not bad for a small organization. This is a good network design that an organization can start with. Then when they have budget, they can put additional layer of security, which we call security hardening. We're going to be discussing that and some other devices that can be introduced to this network to make it more secure as we proceed in this lesson. So if you have not subscribed, this is the right time for you to do that, so that when I actually upload the other lesson, you can be notified. Next on our discussion today is using a network diagram as a security analyst. Network diagrams are topographical maps that show the devices on the network, as we have seen, and then how those devices are connected together. Now, if I don't have a network diagram, I don't have opportunity to use this diagram right now that we have on the screen. As a security analyst, I will not know whether this network is secured or not, because I don't know what is connected to what. So that is why it is very important to actually lay out on a network diagram, okay, which is called topographical map. It shows you where the devices on the network, where they are, what they are connected to, and how they are connected. Security analysts use network diagram to learn about network architecture and how to design network effectively. So that network, if you look at it critically and you discover that this is not secure enough, maybe there is no firewall, you might want to introduce that. So, but if there is no network diagram, you will not be able to do that. Next in this training, we are going to be looking at how do devices on the network, how do they find each other? How do they find themselves? Because we have looked at the network architecture. How do they communicate? What language do they use to communicate? How do they know that this device is in this location that I want to talk to and not in another location? That is what we are going to be focusing on in the next lesson. So I'd like you to check the description section of this video as well for a link to register for my cybersecurity master class, where you are going to have access to the practical lab and also help you to set up a home lab that will not actually cost you a fortune to do that at all. If you have not subscribed, before you go ahead and subscribe now. See you in the next lesson. Bye for now.